What if the key to time travel has been hiding in the laws of physics all along? Imagine standing at the edge of a black hole, where gravity warps time itself, or piloting a ship so fast that years pass on Earth while you experience only days. This isn't just fantasy. Some of the greatest scientific minds have explored how time travel could theoretically work. The strange truth is that according to our current understanding of the universe, time travel might not be impossible. It's just incredibly, overwhelmingly difficult to grasp how time travel could be possible. We first need to understand that time isn't the rigid, unchanging force we perceive in daily life. Einstein's theory of relativity shattered the old idea of time as a universal constant. Instead, time is flexible, stretching and compressing depending on speed and gravity. The faster you move, the slower time passes for you relative to someone standing still. This effect, called time dilation, has been proven in real-world experiments. Atomic clocks flown on airplanes tick slightly slower than those on the ground. Astronauts on the International Space Station experience time a fraction of a second differently, and people on Earth. These differences are minuscule, but they prove that time isn't fixed. Now, imagine pushing this concept to the extreme. If you could travel at speeds approaching the speed of light, say, 99.9% of it, time for you would slow down dramatically compared to everyone else. A 10-year journey at that speed might mean hundreds or even thousands of years pass on Earth. You could effectively leap into the future, returning to a world far ahead of the one you left. This isn't science fiction. It's a direct consequence of Einstein's equations. The only problem, we don't have the technology to build a ship that fast. The energy required would be unimaginable, and the forces involved would tear apart any known material. But in theory, it's possible. Traveling to the past, however, is far more complicated. One hypothetical method involves wormhole shortcuts through the fabric of spacetime. If a wormhole could be created, stabilized, and controlled, one end might be placed near a massive gravitational force like a black hole, where time moves much slower. The other end could remain in a region of normal time. Passing through could allow you to exit at a point in the past. The catch, wormholes are purely theoretical. No one has ever observed one, and even if they exist, they'd likely collapse instantly unless held open by some form of exotic matter with negative energy, something we've never found or created. Another wild idea involves cosmic strings, hypothetical, infinitely thin strands of energy left over from the Big Bang. If two of these strings were to pass near each other at near light speeds, they might twist spacetime in such a way that closed time loops form. Moving along one of these loops could, in theory, send you back to an earlier point in time. But like wormholes, cosmic strings remain speculative. No direct evidence of their existence has ever been found. Even if we could overcome these enormous technological hurdles, time travel to the past introduces paradoxes that defy logic. The most famous is the grandfather paradox. If you go back in time and prevent your grandfather from meeting your grandmother, you would never be born. But if you were never born, how could you have traveled back in time to change events? Some physicists believe the universe would prevent such contradictions through some unknown mechanism, perhaps making time travel to the past impossible. Others suggest that every change in the past could spawn an alternate timeline, creating a parallel universe where history unfolds differently, while the original timeline remains untouched. This idea, known as the many worlds interpretation, offers a way around paradoxes but raises even more questions about the nature of reality. Despite these challenges, scientists continue to explore the possibilities. Experiments with quantum particles have shown that at the smallest scales, particles can behave in ways that seem to ignore our usual understanding of time. Some interpretations of quantum mechanics even allow for retrocausality, where an effect can precede its cause. While this doesn't mean humans can hop backward through time, it does suggest that time may not be as straightforward as we think. Black holes also present fascinating possibilities. Near a black hole's event horizon, gravity is so intense that time slows to a crawl relative to the rest of the universe. An observer watching someone fall toward a black hole would see their time slow down until it appears to stop completely. The person falling in, however, would experience time normally until they were inevitably torn apart by tidal forces. While this isn't practical time travel, it demonstrates how extreme gravity can warp time in profound ways. So, is time travel possible? The answer depends on what kind we're talking about. Traveling to the future is theoretically achievable with our current understanding of physics. It just requires technology far beyond what we have today. Traveling to the past, however, remains in the realm of speculation, riddled with paradoxes and unanswered questions. The universe seems to allow for the possibility, but nature may have built-in safeguards to prevent it. What makes this topic so compelling is that we don't yet have all the answers. Every discovery in astrophysics, quantum mechanics, and cosmology brings us closer to understanding the true nature of time. Perhaps one day, future scientists will unlock the secrets that make time travel a reality. Or perhaps they already have somewhere in a future we haven't yet reached. Until then, the dream of time travel remains one of science's most thrilling mysteries, blending the boundaries between what we know and what we dare to imagine.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.